When you're first learning how to do trigonometry problems, usually everything starts to sort of click for you. But then somebody comes along and says, you remember all of that SOHCAHTOA stuff? Yeah, well that only works for right angle triangles. Oh great, so what are you supposed to do if you've been given a triangle that doesn't have a 90-degree angle in it? Well, that's where two important laws come in, and we'll be looking at one of those laws called the Sine Law. Here we've been given a triangle that looks like this, and we've been asked to find the length of side B right here. Now normally you just would jump right into your SOHCAHTOA stuff and start labeling opposite, adjacent, and hypotenuse. However, if you look carefully at this triangle, there's no 90-degree corner anywhere, so we can't use our primary trigonometric ratios like usual. But even though it's not a 90-degree triangle, as long as we've been given a matching angle, side length, and then one more piece of information, we can solve this using the sine law. And let me show you how. What the sine law does is it compares two ratios, or two fractions if you like. It compares an angle and a side length with another angle and a side length. Let me show you what I mean. I'm going to write sine 35 divided by its matching side length, which is 25. This and this make a pair, and that ratio is going to be equal to the sine of 70 divided by its matching side length, which is the unknown, or b. And we've just set up what's called the sine law. Once we've done that, we need to isolate for b and solve for it. And to do that, we're going to end up doing some cross multiplication, and that's step 2. If you need help with some cross multiplication, please check out an earlier clip called Solving Proportions Cross Multiplication. Essentially what I'm going to do is do b times the sine of 35, and it will be equal to 25 times the sine of 70. So I make a cross. So let's write that out. b times sine 35, and it's equal to 25 times the sine of 70. We're getting closer to solving for b. Now since there's a sine 35 multiplying this b, I need to get rid of it. I need to bring it to the other side. So to do that, I'll divide both sides by sine 35. And then what that does is it cancels out the sine 35 on top with the sine 35 on the bottom. In effect, it makes a big fancy looking 1. So I have 1b left over. And it will be equal to whatever I have remaining here. Now I'm going to get my scientific calculator out because I know I'm going to need that to punch in all of these sines that I have over here. So let's do all of this math in one shot on our scientific calculator. I'll bring that up and I'll punch in 25 times sine, which is right here, sine 70, and I'm going to hit enter to get my answer for the top part of that fraction. Then I'll divide it by sine 35 and hit enter again, and there's my answer. B is 40.9576, or we'll just round that in this case to 41 centimeters. So my final answer is B is equal to 41 centimeters. And there is how you would use the sine law to solve for the side length of a triangle that's not a 90-degree triangle. Okay, so remember your first step, you're going to write one proportion and set it equal to another proportion. Then in step 2 you'll cross multiply and isolate for your variable, and then finally you'll punch whatever you have left in on your scientific calculator and solve for the side length. And now it's your turn to try out the sine law. I'll give you a triangle that looks just like this, and you'll notice it has no 90-degree corners, and you're being asked to solve for the length of side D right here. So try and follow the steps I showed you on the left and solve for the length of that side. Your solution is d is equal to 64 meters. And we got that by first setting up two ratios or fractions, just like this. And then in step 2, we cross multiplied to get this line right here. Then we have to isolate for d, which means we have to divide both sides by sine 58. And finally, we entered this into our calculator and arrived at 64 meters.